Hey Super Nerds. So today we're going to talk about coal seam gas and aluminium, and in particular getting it out of the ground and some of the problems associated with that. And then when we're finished talking about aluminium, we're going to move on to the aluminium cycle, which is not a natural cycle, it's a cycle that we've made, which allows aluminium to be recycled. So, coal seam gas. Basically, it's natural gas and it's about 95 to 97% methane. And it's found in coal seams, so where coal is, at depths of about between 300 to 1,000 meters underground. And it's sometimes referred to as coal bed methane, but we are going to talk about it as coal seam gas from now on. And this is how we get it. So, first, you find where you think there is coal seam gas, and once you've tested for it, all is good. So this is a best case scenario. So first step is we drill a hole down to where we think it is, and we pump water down, very like high pressure water. And in this water that we're pumping down, it goes right down here into the coal seam, the coal bed. It's essentially water, sand, and chemicals, usually glass, like silicates like glass and whatnot. So we pump that down, and it gets into the little cracks in between here, and it breaks it. The whole point is that it then breaks the coal apart. And by breaking the coal apart, because the coal is non-porous, by breaking the coal apart, eventually the gas starts to, where are we at? Where's my mouse? The gas starts to go, the gas starts to loosen up here and then flow out with water. So water and gas come back out of the pump. So we pump water down, break it apart, and then the gas, the holes where it breaks, it gets filled up with sand and glass. And by filling it up with sand and glass, the sand and glass is porous. Because it's porous, this means, so it's got little holes in it, you can see that there, the gas, coal seam gas, is able to flow through it and up the pipe. And it's collected out of the top. Now that in itself sounds pretty good. Like that sounds like it's not a bad thing. However, the downside to it is that it can potentially ruin the water. So for example, or the groundwater. The gas has potential to contaminate the groundwater or the water table as it rises through the lithosphere. For example, if we go back here, we can see here is the water table, okay? And you can see once we've cracked it, if it flows straight up that pipe, it's not a drama, but the chance of it doing that is actually not great. And there's a good chance that it will flow up through the porous rocks here into the water table as we go through there. So it could contaminate the water table. At the moment, there is a coal seam gas mine planned for the New South Wales Liverpool Plains, and it has been estimated between 0 and 30% chance of contamination of the water table. That's by the scientists. Some people say that that's a good enough level to go ahead. Other people, particularly those who rely on the water for farming, are saying no, it's not good enough chances. It's possible. Now, there has been contamination in Queensland. There is currently a river, I can't quite remember the name of it, there's currently a river that has methane bubbling through the river. Now, the mining company that's responsible for it says that this is a natural occurrence, even though it never happened before they fracked in the area. So, the water table is the level below the ground, which is saturated with water. So that's actually where, if you drill a hole down to get some water out of the ground, so bore water, that's where it's coming from. Now, these here are the oil and gas basins throughout the country. Okay, so this is where we can get gas, roughly. And we're looking at roughly this area here. Now, what's interesting is if we look at that, over there is the underwater, the water under the ground. And this is the Great Artesian Basin. And this is where roughly 40% of Australians get their water from. It's likely, it's up to 30% chance that this body of water will be contaminated because of the fracking. So we need to decide whether or not that's a good thing. All right, so let's move on to aluminium. Now, aluminium itself is an ore called bauxite. Bauxite, it's a type of clay that we dig out of the ground, and it's purified. We won't go into how, we don't need to go into how, into a powder of aluminium oxide. And this is what we get aluminium from. So we do this by electrolysis. Lysis means to split in half or split. Electro means with electricity. So we split this aluminium, so here's the chemical, aluminium oxide. We split that with electricity into aluminium and oxygen. So the aluminium sinks down the bottom here. It's done at a very high temperature, about 950 degrees Celsius. So the aluminium sinks down to the bottom because it's hot, it's melted, and it gets poured out there. And it sounds pretty simple, and it kind of is simple. But yeah, so that's how we separate aluminium from bauxite. However, aluminium itself is quite it's very hard to get out of the ground. So what's easier than getting out of the ground and more energy efficient is recycling it. So one thing we can do is we collect our aluminium, we bag it up, it gets separated. There's several ways they do it. One is by manual selection, and the other is by using magnets to pull out all of the because aluminium is not magnetic, so it pulls out all of the magnetic metals that come with it, etc. And it gets crushed along. It gets slugged. Slugged means it gets turned into the cubes, pressed into the cubes, which then gets crushed. And again, magnets are used to purify it that little bit more in case there were some errors in the metals going through. And then it gets melted and it gets turned into ingots, I-N-G-O-T. Ingots, that's what this is, which then get rolled out and then turned back into metal again, or turned back into useful aluminium. And that's the cycle. So we'll see you in class. Enjoy.